Good morning. In this video we will see the practicals, determination of electrical conductivity by using conductivity method. I am Dr. R. SINGARAVEL, Professor, Department of Soil Science and Agriculture Chemistry, ANNAMALAI University. Electrical conductivity of the soil is determined using conductivity meter. The method is conductivity method. The principle involved in this experiment is the method is based on the principle that conductivity of a solution of salt is proportional to the concentration. When the concentration of salt increases in a solution, the conductivity of salt will also be more. So, salt, for example, NaCl, KCl, so it has cations and anions, K plus, Cl minus. So, when you put the conductivity cell, the ions will move towards the electrode and produce electric current, which you measure and give it as a reading, or electrical conductivity reading. More the salt, more will be the concentration. So, that is the principle. We know that solution offers some resistance to the passage of electric current through them, depending upon the concentration and the type of ions present. So, it is a principle we know already. Higher the salt content, lesser is the resistance. More the salt content, more readily the current will be conducted, or less will be the resistance to the flow of current. So, resistance and conductance are opposite phenomena. More the salt, more will be the conductance, less will be the resistance. The resistance is defined by the Ohm's law as the ratio of electric potential in volt and the strength of current in amperes. So, resistance is measured by Ohm's, which is given by R is equal to V by I. V is the volt and I is the strength of current. I is the strength of current. Electrical conductivity or conductance is the reverse of resistance. So, already we saw that resistance and conductance are opposite. More the resistance, less will be the conductance. So, it is the reverse phenomena. So, the conductance is reverse of inverse of resistance, 1 by R, 1 by R, 1 is equal to 1 by ohm. So, the reciprocal of ohms is mhos, reciprocal of ohms is 1 by ohms is equal to mhos, 1 by ohm is equal to mhos, the unit of measurement is mhos. The electrical conductivity values are since low in most of the soil, solution, irrigation water. It is usually expressed in terms of millimhos per centimeter or micromhos centimeter. Now, it is being replaced as decisiemens per meter. When you write, we have to be very careful. The method is small d, capital S, a space, m power minus 1, decisiemens per meter. The unit of expression of conductivity is decisiemens per meter. The procedure to find out the electrical conductivity: weigh 20 gram of soil and then transfer to a 100 ml beaker, add 50 ml of distilled water, stir with a glass rod and allow to stand for half an hour. Alternatively, what you can do is use the same soil water extract which was used for the determination of pH. So, after measuring the pH in the pH meter, the same solution we can use it for determining the EC of the soil. So, that alternatively the soil water suspension prepared in pH estimation can be used for the determination of electric conductivity as well. The procedure is switch on the electrical conductivity meter. So, before taking up reading in any instrument, you have to calibrate or standardize the instrument. So, in the electrical conductivity meter should also be standardized. So, for standardization, use saturated gypsum solution. CaSO4 solution or 0.01 potassium chloride solution. So, this gives an EC value of 2.2 decisiemens per meter or 1.41 decisiemens per meter. The calcium carbonate saturated calcium sulphate solution gives EC of 2.2 decisiemens per meter. The 0.01 KCl solution gives EC value of 1.41 decisiemens per meter. So, first switch on the pH meter, then wash the electrode, then wipe out the excess moisture outside using the filter paper, then you feed the standard solutions, saturated gypsum or saturated gypsum or 0.01 KCl. Usually we prepare 0.01 KCl. So, we feed the 0.01 KCl solution, adjust the EC meter reading to 1.41 decisiemens per meter. Now, you have done the standardization part. Now, immerse the soil water extract and dip the electrode and take the reading. So, that completes the reading of the electrical conductivity. I repeat the procedure: weigh 20 gram of soil, transfer to a 100 ml beaker, then add 50 ml of distilled water, put a glass rod, stir it intermittently for half an hour. Otherwise, you use the same soil water suspension prepared in a similar way for the pH determination can also be used for EC determination. Now, standardize the instrument by switching off, give some time up for warming up, then you wash the electrode with distilled water, wipe out the excess moisture outside with filter paper, then you introduce the 0.01 KCl solution prepared, standard solution prepared, dip the electrode and then adjust the knob to read 1.41 decisiemens per meter. Then afterwards you wash the electrode with the distilled water, wipe out the excess moisture, then you put the soil water extract prepared for the EC determination and then dip the electrode, then note the reading. So, that completes the determination of EC value. The EC value will be expressed in decisiemens per meter, decisiemens per meter, decisiemens per meter. Thank you.